In this lecture, we'll continue our discussion on cloud security. In previous lecture, we saw the 9 threats identified by CSA. In today's lecture, we'll talk about key security challenges for cloud applications. So there are 6 key challenges. First one is authentication. So authentication refers to digitally confirming the identity of the entity requesting the access to some protected information. So in a traditional in-house IT environment, authentication policies are under control of the organization. However, in cloud computing environment where applications and data are accessed over internet, the complexity of digital authentication mechanism increases rapidly. Therefore, alteration of authentication and authorization policy requires the involvement of cloud service provider system and services. Next challenge is authorization. So authorization refers to digitally specifying the access rights to the protected resources under access policies. So in a traditional in-house IT environment, these policies are controlled by the organizations and they can be altered at their convenience. However, in a cloud computing scenario, authorization requires the use of cloud service provider services for specifying the access policies. Third challenge is security of data at rest. Due to multi-tenant environment used in cloud, the application and the database servers of different applications belonging to different organizations can be provisioned side by side on the same physical infrastructure, increasing the complexity of securing the data. Now, since these applications are or the database servers, these virtual machines are hosted on the same physical machine. Therefore, an appropriate separation mechanism is required to ensure the isolation between applications and data from different organizations. That is, the isolation of these virtual machines has to be guaranteed and has to be maintained. Next challenge is security of data in motion. So data at rest, by data at rest, we means the data which is stored in the server in the data center. Data in motion is when the data is in transit between the user and the data center, cloud provider's data center. So in a traditional in-house IT environment, all the data exchanged between the application and the user remains within the organization's control and geographical boundaries. However, in a cloud computing environment, the data applications and data are moved out of the in-house IT infrastructure to the cloud provider. Therefore, appropriate security mechanisms are required to ensure the security of data in and while in motion. Fifth challenge is data integrity. So data integrity ensures that data is not altered in an unauthorized manner after it is created, transmitted or stored. Now, due to outsourcing nature of cloud computing, the data stored in the data centers to ensure the integrity of that data is extremely important. Finally, auditing. Now, auditing is very important for applications deployed in cloud computing environments. So, when the infrastructure is on the premises, that is for traditional in-house IT environments, organizations have complete visibility of their application and access to protected information. However, in cloud computing environment, auditing mechanisms are required to get the visibility into the application, data accesses and action performed by the application user, including mobile users and devices such as wireless laptop and smartphones. We'll look at these six key challenges and the solutions for them in detail in today's lecture. But before that, let us look at CSA Cloud Security Architecture. So CSA is a Cloud Security Alliance. It provides a trusted cloud initiative reference architecture, which is called as TCI reference architecture. Now, TCI is a methodology and a set of tools that enable cloud application developers and security architectures to assess whether their internal IT and their cloud providers are in terms of security capability to plan a roadmap to meet security needs of their business. So, this TCI architecture has 7 subdomains. They are governance, risk management and compliance, information security and management, privilege management infrastructure, threat and vulnerability management, infrastructure protection service, data protection, and policies and standards. So let us look at this architecture. So let us talk about these subdomains: governance, risk management, and compliance. So this subdomain deals with identification and implementation of appropriate organizational structure, processes, and controls to maintain effective information security governance, risk management, and compliance. Next subdomain is information and security management. This deals with implementation of appropriate measurements in order to minimize or eliminate the impact that security related threats and vulnerabilities might have on an organization. Next subdomain, which is privilege management infrastructure. This subdomain, the aim of this subdomain is to ensure that users have access and privileges required to execute their duties and responsibilities with identity and access management functions. All functions like authentication, authorization service, everything comes under this subdomain. Next subdomain is threat and vulnerability management. So basically it deals with the core security such as vulnerability management, threat management, compliance testing, and penetration testing. Next subdomain is infrastructure protection service. The objective of this subdomain is to secure the server, endpoints, network, and application layer. Data protection subdomain deals with the data lifecycle management, data leakage prevention, intellectual property protection with digital right management, cryptographic services such as key management, etc. And finally, the last subdomain is policies and standards. Security policies and standards are derived from risk-based business requirements and exist at a number of different levels, including information security policy, physical security policy, infrastructure security policy, etc. So let us look into detail in the 6 challenges that we spoke about. The first one is authentication. So we understand that authentication is about confirming the identity of the user or any entity requesting to access the protected information. So the process of authentication involves, but is not limited to, validating at least one factor of identification of the identity to be authenticated. A factor can be something the entity or the user knows, for example, password or a PIN, or something that user has, for example, a smart card, or something that can uniquely identify the user, such as fingerprints. So authentication can be done in multiple ways. If it is a multi-factor authentication, then more than one of these factors can be used for authentication. So there are various mechanisms for authentication. The first one is SOS, which is single sign-on. Then the second one is SAML token. SAML token stands for Security Assertion Markup Language. And the third one which lecture is OTP, that is one-time password. Let's look into these mechanisms for authentication. Single sign-on. So it enables user to access multiple systems or applications after signing in only once for the first time. So once the user signs in, the identity of the user is authenticated, then there is no need to sign in time and again. Since different systems or applications may be internally using different authentication mechanism, SSO upon receiving initial credentials translates to different credentials for different systems or applications. So benefit is it reduces human error, saves the time spent in authentication with different systems or applications with the same identity. And there are different implementation mechanisms. We'll just see that how these are implemented. So basically, a single sign-on is that user has to the user authentication is done only once, and once the user does the authentication, the user is not required to sign in again. So that is why the name says single sign-on. Mechanisms of single sign-on, SAML token and Kerberos. We'll look at SAML token in detail. So let us look at this. So SAML token is basically security assertion markup language. It's an XML based open standard format for exchanging security information between the identity provider and the service provider. So let us look at the authentication flow. So when a user tries to access a cloud application, a SAML request is generated and the user is redirected to the identity provider. The identity provider parses the SAML request and authenticates the user. Then an SAML token is returned to the user, who then accesses the cloud application with the token. So SAML prevents man in the middle and replay attacks by requiring the use of SSL encryption when transmitting assertions and messages. So SSL is a secure socket layer. It's an encryption based internet security protocol. And replay attacks, basically replay attacks is a form of network attack in which a valid data transmission is somehow maliciously repeated or delayed. So for example, user had sent some message, but in between the attacker, gained the in between the attacker gained the access to that message, and then it replayed that authentication message at a later time, which created ambiguity, and it could also gain access by replaying the authentication message at a later time. So another authentication mechanism which is prone to replay attacks, that is, which is not vulnerable to replay attacks, is a one-time password. So basically, one-time password is a authentication mechanism, and it uses passwords which are valid only for single use and for a single transmission or session. So the authentication, so basically these kind of authentications which are based on OTP are secure. Text messaging, that is SMS, is the most common delivery mode for OTP. This is the most widely used. All of us must have used OTP for authentication sometime or the other. The most common approach for generating OTP tokens is time synchronization. So basically, a time-based OTP algorithm, they are popular time synchronization-based algorithms for generating OTPs. So basically, OTP is robust because it is not prone to replay attacks. Because that OTP, it will be valid only for a very small duration of time. Next, let us look at authorization in detail. So we know that authorization refers to specifying the access right to the protected resource using access policy. So OAuth, it's an open standard for authorization that allows the resource owner to share their private resources stored on one side with another site without handing out the credentials. So let us look at this. So in an OAuth model, an application which is not the resource owner requests access to the resource controlled by the resource owner. So we have a cloud application here. We have the user here. Let's say this is the resource owner, and then there is a client here. So there is a request for resource, and it is redirected to the cloud application for authentication. Then the response from the cloud application asking the resource owner to authenticate. Then the resource owner will send the authentication back. Then the cloud app issues a token to the client, and finally the client confirms the access to the user. So in this model, an application requests access to the resource controlled by the resource owner. Resource owner grants permission to access the resources in form of a token and matching shared secret. Moreover, tokens can be issued with a restricted scope and limited lifetime, and they can be revoked independently. So, a limited lifetime is important because after certain time it should expire, so that even if attacker gets hold of the token, it cannot reuse it at a later time. Diagram here is showing the OAuth flow. Next is identity and access management. So basically, identity and access management, it provides a method for digitally identifying person and maintaining associated identity attributes for the user across multiple organizations. Access management, it deals with the authentication it deals with authentication of the user, and basically the access policies, authorization and access policies. So depending upon the role of the user, depending on its privileges, it will be able to access some data, right? So identify and access management deals with users' identity, their authentication, authorization, and access policy. So let us look at this example here. It shows an example of a role-based access control framework in the cloud. So basically, if a user who wants to access an application in the cloud is required to send his or her data to the system administrator, who assigns the permission and access control policies which are stored in user role and data access policy database. So user will send the credentials. Credentials will be verified based on the credential database. Then the user role will be verified using user role database, and based on this data access policy database will also decide that what a user of this particular role can access. Federated identity management. So federated identity management, basically what it says is that if there are multiple domains and the user has been authenticated in one of the domains, it can also access the other domains without having to go through the authentication process again. And federation will be enabled through a single sign-on. So any mechanism, SAMA, such as SAML token or Kerberos. And and it provides a role-based access control. So it is used for restricting access to confidential information to authorized user, and these access control policy allow defining different roles for different users. Next, let us see securing data at rest. So basically, when we say data at rest, we mean to say it is in the servers in the data center. It can be in the form of tables, records, files, or it can be raw data, or it can be on a distributed storage or a storage area network. So how is data at rest secured? It is done through encryption. So basically, what is an encryption? It is a process of converting a plain text into ciphertext, and decryption is the reverse process. So encryption is of two types, symmetric and asymmetric. So basically, symmetric encryption uses same secret key for both encryption and decryption, and the secret key shared between sender and receiver. So symmetric encryption is best suited for securing data at rest, since data is accessed by known entities from known locations. And these are some examples of the advanced encryption standards. Asymmetric encryption, on the other hand, it uses two keys. One will be for encryption and the other is for decryption. The encryption key is also called as a public key, and the decryption key is also called as private key. The two keys are linked to each other such that one key encrypts plain text to ciphertext and the other decrypts ciphertext back to plain text. So public key can be shared or published, while private is only known to the user. So this diagram basically depicts the process of asymmetric encryption. Plain text gets encrypted and converts to ciphertext, and it is done through public key, whereas ciphertext gets converted back to plain text by the process of decryption, which requires a private key. So basically, asymmetric encryption is best suited for securing data that is exchanged between two parties, where symmetric encryption can be unsafe, because if attacker gets the secret key somehow, then it can decrypt the data. In asymmetric encryption, a separate key is used, and for decryption, there is a key which is kept in private. Next is securing data in motion. So when the data flows between client and server over a potentially insecure network, it is very important to maintain the security and the integrity of the data. So confidentiality means limiting the access to data so that only authorized users can access it. Integrity means data remains unchanged when it is in transit from source to destination. So data integrity, it ensures that data is not altered in an unauthorized manner after it is created or transmitted or stored. So transport layer security, TLS, and secure socket layer, that is SSL, are the mechanisms for securing data in motion. So both of these, they are used to encrypt web traffic using HTTP, that is Hypertext Transfer Protocol. So they use asymmetric cryptography for authentication of key exchange, symmetric encryption for confidentiality, and message authentication code for message integrity. So the TLS handshake protocol is summarized in this diagram here. So in this, the client first sends a hello message to the server. So this is the client here, this is the server, and it sends a hello message. So what does this message contains? It contains the protocol version, it contains a random number, and the information on the private key. A server sends back the response back to this message by a server hello message, which also contains the random number and the version chosen and the settings for private key encryption. Then the server sends its certificate, and it also sends the server hello done message saying that it has completed the handshake negotiations. Then the client sends its certificate to the server. After this, what will client do? It will create a session key. So it creates a session key uh, encrypted with server's public key. So the session key which is created is encrypted with server's public key, and it sends the encrypted session key to the server. The client also sends a certificate verify message, which is basically a digital signature. So this can be verified using client certificates public key. Next, what will happen is that client and the server communication to each other is that the data will be exchanged from now on will be encrypted using the session key which has previously been exchanged. And finally the client sends, so finally this last step is finished where the client sends an encrypted message indicating the end of handshake session. So this is the summary of transport layer security protocol. Next, let us look at the management of encryption key, which is an very critical to ensure the security of encrypted data. So basically, it has different phases. That is the creation. So this is the first step. So keys must be created in a secure environment and must have adequate strength. Next is backup. So backup of the keys must be made before putting them into production, because in the event of loss of key, all encrypted data can become useless. Third is the deployment phase. In this, new key is deployed for encrypting data, and deployment involves rekeying the existing data also. The fourth phase is the monitoring phase. Basically, after a key has been deployed, monitoring the performance is done to ensure that key has been deployed correctly. A rotation key, basically it involves creation of a new key and re-encrypting all the data with a new key. And so next phase is expiration, which basically this phase will begin after the rotation phase is complete. Next is archival. So basically, archival is a phase before the key is finally destroyed. So it is to archive the old keys for some period of time to account, to basically take care of the scenarios where there is still some data left in the systems which is encrypted with this old key. And finally, last phase is destruction of the key. So where the expired key will be destroyed after ensuring that there is no data which is encrypted with the expired key. So basically, this figure here shows the example of key management approach. All the keys for encryption must be stored in data store, which is a separate and distinct from actual data store. So this is encrypted key data store. Additional security features such as key rotation, key encryption can be kept here. Finally, the last challenge is auditing. So basically, auditing is mandated by most data security algorithm, and it requires that all read and write access to be data to be logged. So logs can include the users involved, type of access, timestamp, action performed, and records accessed. So basically, auditing is that whatever accesses have been made to the data, all of them needs to be recorded. And the main purpose is to find out the security breach so that necessary changes can be made in the application and deployment to prevent further security breach. So let us see what are the objectives of auditing. Uh, it it is first is to verify efficiently and compliance of identity and access management control as per established policy. Second is verifying that authorized users are granted access to the data based on their own roles. Right, this is very important. Maybe a user with a different role may have a different access privilege. Then verifying whether the access policies are updated in timely manner upon the change in role of user. The fourth one is verifying whether the data protection policies are sufficient. And finally, assessment of support activities such as problem management. Thank you.